we're going to start a section on counting atoms, which will eventually lead into writing balanced formulas and balanced chemical equations. And so it's really important that you guys start to understand how to count atoms within a chemical formula first. If you can't do this, then you cannot progress through this section. So we're going to go through some of the rules, and it's really important that you follow the rules when you're counting atoms. I would recommend that when you count atoms, it's best to make a list of the different types of atoms. That helps you keep track of them. Another major thing before we can start with the rules is that you understand that each capital letter represents a different element. So if we have NaF, the two elements that we would list out would be Na sodium and F fluorine. This is a pretty simple formula. There's no subscripts. So we're just looking for capital letters. And so we have Na, so it has one capital letter, so that's one element. And then the next capital letter is F, so that represents the next element. Some other chemical formulas that you are familiar with are H2O. So there's hydrogen and oxygen, so our list would be H and O. There's sodium chloride, which is table salt, and so again, capital letters only represent the elements. Sometimes they have a lowercase letter. It's going to be very important that when you are writing formulas and making these lists that you pay attention to the capital letters and the lowercase letters, okay? So rule number 1 is if there is no subscript, it is assumed that there is one of each element. And so it's important to first understand what a subscript is. So a subscript is a number, just like in typing a subscript, it's a number that is written down below. And so when we're talking about water, H2O, the subscript is going to be the 2. So notice how it's written down below. It should never be written like this, okay? That's not a subscript and that's not a proper chemical formula. And so it needs to be written little and down below. So if there is no subscript, so let me just get rid of this so we don't confuse ourselves, it's assumed that there is one of each element. So some common formulas would be sodium chloride, and so what we would do is make a list. So we have chloride and sodium, and it's going to be assumed that there's one of each one atom of each element. So there's one sodium and one chloride, and so we'd write a 1 and a 1. Some other formulas could be hydrogen bromide, and so again, making our list, it's really important to do. For these simple ones, it might seem silly to make a list because you can obviously see pretty easily how many of each there are, but we're going to be dealing with some complicated ones, and so it's good practice that we get used to making these lists. Another example of a chemical formula with no subscripts, sodium bromide. So sodium and bromide. So again, making your list, NaBr. There's no subscript, so it's assumed that there is one of each. Rule number 2 is the subscript, which is the number written down below, like I just explained to you, goes with the atom directly before it. A chemical formula can have multiple subscripts. So, for example, if we take nitrogen oxide, which is N4O10, the 4 goes with the nitrogen and the 10 goes with the oxygen. So making our list, nitrogen, oxygen, those are our different elements that are involved. We have 4 nitrogen and 10 oxygens. Sometimes they can be a little bit trickier. So if we have NaHCO3, again, making our list, so Na is one element, H is one element, C is an element, O is an element. There's no subscript with the Na, so that's 1. There's no subscript with the H, so that's 1. There's no subscript with the carbon, so that's 1. And there is a subscript with the oxygen, so that is 3. So it's important that you don't put a subscript with the wrong element. So one more. So if you have iron oxide, the 2 does not go with the oxygen, the 2 goes with the iron, and the 3 goes with the oxygen. So make a list, FeO, 2 Fe's or ions and 3 oxygens. So far everything has been pretty straightforward, maybe even a review for some of you. But once you start adding parentheses into the formulas, things start to get a little bit trickier. And so if there are parentheses, that means that you'd have parentheses around part of the formula. The subscript that is outside the parentheses is distributed or multiplied to everything inside the parentheses. So let's look at what that would mean. If we start with, let's say, aluminum hydroxide. So here comes our parentheses. Okay, and so we're going to make a list of our elements. So we have Al, O, and H. Al, O, and H. And so Al does not have a subscript, so it's 1. But now we have some parentheses. And so the parentheses mean that this 3 gets multiplied by everything inside them. So essentially what you're doing is 3 times 1 equals 3 oxygens, and 3 times 1 equals 3 hydrogens. Sometimes the elements inside the parentheses are going to have subscripts of their own. So let's look at a pretty complicated one. So we have Ca, C2, H3O2, all in, that's a 2, hold on. O2, it's not much better. All in parentheses with a 2 as a subscript outside of it. And so now we need to make our list. So we have Ca, C, H, and O. And the Ca does not have a subscript, so there's 1 of those. But now this 2 outside the parentheses needs to get distributed to everything inside, and we're multiplying, not adding. So we're going to go 2 times 2 is 4 carbons. 2 times 3 is 6 hydrogens, and 2 times 2 is 4 oxygens. So let's do one more of those. It's a little bit trickier. So we're going to have Ga, gallium, with a subscript of 2, parentheses, Cr2O7, with a subscript of 3. Okay, so a lot going on with this one. So we have Ga, O, and Cr as our elements. So Ga in this case does have a subscript, so there's 2. The parentheses, it is not inside the parentheses, so this subscript doesn't have anything to do with the Ga. It does have to do with the Cr and the O, however. So 2 times 3, we're multiplying, is 6, so there's 6 Crs, and then 3 times 7 is 21, so there's 21 oxygens. Our last major rule, Rule 4, is dealing with coefficients. Coefficients are numbers that are written in front of a chemical formula. They're going to be large numbers, they're not written as subscripts. And they are distributed to everything in the formula, meaning that you multiply all other subscripts by the coefficients. When you have a coefficient, you're basically increasing the number of molecules of that formula that you have. So for example, if we have 3H2O, that means that we have 3 water molecules. So we have 1, 2, 3. Okay, so that's what that 3 means. It means that there's 3 water molecules. And we're going to distribute it to everything. So we're going to multiply it by every coefficient. And so if we make our list, hydrogen, oxygen, 3 times 2 is 6. 3 times 1 is 3. That's a pretty simple one. This is pretty much as complicated as they get when you have coefficients and subscripts and parentheses. So let's take a look at one of those. So if we take 4 AU, parentheses, IO, 3, close parentheses, 3. So let's list out our elements. So AU, IO. And so we're going to start with our coefficient. And so our coefficient gets multiplied to everything behind it. So there's 4 AUs. 4 times 1 is 4, so there's 4 right now for the i's, and then 4 times 3 is 12. So right now there's 12 oxygens, but we're not done because we also need to multiply the subscript outside the parentheses. And so we're going to say 4 times 3 times 4 is going to be 12. So there's going to be 12 i's, and then 3 times 12 is going to be 36. So there's 36 o's. And so this is pretty much as complicated as it can get because you have parentheses and coefficients. I'll look at one more. So let's do one that looks a little different. 2 parentheses NH 4, close parentheses 3, N. All right, so now the parentheses are in a different spot. So they're not always with the negative ions, so this time they're in the front. And so we're going to list out how many different elements do we have. We really only have 2, right? We have N and H. When an element appears in 2 different spots, you're going to add their totals together. So multiply it out like you did before, and then add your totals together. So 2 times 1 is 2, so there's 2 nitrogens there. 2 times 4 is 8, and 2 times 1 is 2. Okay, now we need to do our subscript outside of our parentheses. So 3 times 2 gives us a total right now of 6 n's. And we're going to take that total, the 6 n's, and add it to those 2 n's. So our total number of n's is going to be 8. And then for our subscript outside, we've already done the 2 times the 4 is 8, and so now we're going to go 3 times 8 is 24. So, I hope that you are starting to understand this a little bit. The good thing about counting atoms is that all the formulas are treated the same way. So once you learn the rules and you can learn to apply them, it doesn't matter how complicated the formula is, you can count the atoms in that formula. Just remembering to distribute the coefficients to everything behind it. Subscripts outside of parentheses only go to things inside the parentheses, and that if you have an element that appears in more than one spot, treat it like it's an individual element and then add their totals together. Good luck on your worksheets, and I'll see you soon.